Assalamualaikum warahmatullahi wabarakatuh. Indonesian teenagers, high schoolers invited to USA to present their idea and solutions about grand challenges for engineering in the 21st century. That is something and a rare occasion. A half-globe international journey to discuss problem and applying STEM approach to forge global collaborations among the world's tech generations, that is never before. I am really honored to be their mentors of this Indonesian next generation and to coach them on their engineering and their precious journey. I wish them all the best and hope they all learn a lot from this event to make up a better world to live in. Assalamualaikum.
To lead a team of 15 years old high schoolers in solving the grand global engineering problem, developing idea, designing and building a robot with a new kit and new programming language that is never in my present experience.
My gosh, I got the robot, I'm putting it together, and I'm about to go out on a plane to get to America. I gotta say thanks for the help you gave me. We were often building this plane as we were flying it, but it's gonna land safely at Constitution Hall after you get out your own plane at Dulles Airport International, and we're there to greet you. And Liz Tweed is holding up a sign in everybody's language saying, "Here we are. Welcome to America."
Today, the world is advancing. Somehow it also creates many problems such as pollution, clean energy, food distribution, access to clean water, and many more. As we already know, access to clean and drinkable water has proven to be a potent source in nations throughout the world. But more than 1 million people do not have that access, and it is causing more deaths each year. This could be the global problem to be solved. Providing access to clean water is one of the 14 grand challenges for engineering. The issue is to make a healthy life for the people from all over the world. First Global is taking this issue as the focus of their robotic game. Every year, First Global team from all over the world join the challenge and pursue STEAM education. This year challenge will require us to cooperate and compete against other teams from different countries to accomplish engineered tasks. Indonesia is one of the countries that has the same problem in having access to clean and drinkable water.
Indonesia is one of the richest nations in terms of its biodiversity. With its unique two seasons, rainy seasons and dry season, it gives us a huge rainforest and a lot of rivers. But unfortunately, we are still facing a problem in some area in terms of accessing clean water. This is the problem we are trying to address in this first global robotic competition. We challenge our students to design and build a robot that can purify rivers, collecting waste and throw them away and get the clean water as much as possible.
I'm the project leader of the team. I manage our team's collaboration, robot designs, and progress. I've always liked robots since I was little, and since then I've been discovering them in real life.
STEAM is an educational approach to learning that uses science, technology, engineering, the art, and math as access points for guiding student inquiry, dialogue, and critical thinking. During the project of making robots to simulate an access to clean water, the students exposed to a real problem and using STEAM approach to propose a solution to the problem. In science, for example, several science standards address physics, mechanics, forces, motion, velocity, acceleration, and energy transfer, as well as conservation were discussed. The technology in building robots vary from structures, mechanics, electronics, and computing, including the use of IMU, Inertia Measurement Unit, the 9 degree of freedom electronic gyroscope instrument inside the control hubs, the technology of hex motor, which is embedded with an encoder to count the motor rotation and then transfer its measurement to define displacement. Late technology of programming, the Wi-Fi connection from tablet to control hubs, the use of smart servo motors were also discussed. In engineering, the team first learned how to understand the task, define main function, and dividing its main function into several sub-functions such as mobile exploring, collecting balls, lifting the balls, identifying the balls, and sending it to the appropriate storage, depositing waters and contaminant into laboratory and water reserve, and finally, elevating the robots off the ground. After making function lists, a series of engineering designs were carried out on the computer using CAD system, designing its shape to satisfy each function. Concurrently, the logical algorithm of the robot response was designed and flowcharts were developed for each class of functions. Before the kids arrived, the detail of the test field was given. Then we decided to build a full-scale field test in order to simulate the match. By April, the robot kits arrived. With delight, students start playing, experimenting with new kit and new control, and new programming language. A number of proposed designs were constructed, built, and assembled. The built robot was then undergo several testing in order to see its performance to the specific task. The test result was then reviewed and used in optimizing the robot for the final design. By making this robot, the whole engineering process and design cycle were undergone in producing the final solution. The art involvement during this project were on coding, as we choose to use Java language instead of block diagram. The other area of art is in making presentation and video documentation that will be submitted to Sofia Kleskaia Award. Finally, the math standards were dominantly present on the project, as the students exposed to Cartesian diagram, gradient of line, and its reference to velocity, integration over the time to get distance, measuring angle, and calculating the tangential angle for shooter and angle for elevating of the shooters. The STEAM approach providing a vehicle for one to apply theory into a practical problem. The team shown to have thoughtful risk, engage in experimental learning, persist in problem solving, embrace collaboration, and work through the creative process.
Presenting an idea and getting sponsor. I have never done this before. It's a new, scary and fun experience.
During our bootcamp, I have to take pictures. Learning producing professional pictures with a tight timeline, lack of sleep, eating and working, and I even have to dish on our own plate after eating. That is never before.
Building robot with new experience, new kits, new programmings. It's fun.
It's my first time to use Java on Android Studio to program the robot. it's never before.
Communication with other team with the different language and culture is a new experience for me. It's never before.
It's my first time building a robot collaboratively, from designing, programming, and building that never before.
I was afraid that we could not get the visa, as I heard USA visa is pretty hard, but we managed to get it well.
First of all, I'm glad to be a part of the team. Never before I decided to be part of the robot such and condition. I'm a bit sad because I couldn't go to USA, but I will work to be the next year candidate. Never before I have this strong feeling to prepare the future.
Preparing the robot gave me this mixed feelings of afraid, worried, and stressful. But at the same time, I also feel fun and excited. Feelings like never before.
It feels so awesome having a new experience in building a robot with my friend.
I have never fly to other country. It's going to be the first time I'm going abroad and go to United States.
I wish a fruitful participation.
I wish I can make friends in the competition.
I wish learning from the event.